Hey guys, welcome to day one of my STEM project. This is Veera here, and I hope you guys are having a great day. Now, before we get started on our first lecture, I just wanted to remind you guys that there is another video that has been assigned to you guys for today on Google Classroom, and I want you guys to check that video out before starting on today's lecture because that video is the official start to our 3-week Python course. So if you haven't checked that video out, go ahead, watch that video, then come back to this lecture. And if you have, then let's get started on today's lecture. So today we're gonna start off pretty light. We're gonna do some basically theory. We're not gonna start any coding. So today we're just gonna take a look at the history of Python, some key features of Python, and also what Python is used to build in the real world. And the reason I do this as our first lecture is because number one, I wanted to start off with something light. And then number two, learning about these three aspects of Python, its history, its features, and its applications, will help us understand all the capabilities that Python possesses, and it will also help us visualize all the possibilities that Python opens up for us as developers after we learn the language. So my goal is that by the end of this video, you guys have some cool projects in the back of your head that you guys want to build with Python after you learn the programming language. So that's the main goal of this video, just understanding how powerful Python is and what you can build with it. So we're going to start today's video off by taking a look at the history of Python. So Python was actually created way back in 1980 by a man named Guido van Rossum. And Guido van Rossum was actually a researcher at the National Institute of Research in Mathematics and Computer Science. And he built the Python programming language during his winter break because he just felt bored and he wanted something to do. Now, I don't know about you guys, but I find that fascinating because one of the most popular programming languages to date was made by Guido van Rossum just because he felt bored. So yeah, that's quite an interesting fact about Python. And also another interesting fact about Python was that it's not named after the snake, but it was named after Guido van Rossum's favorite TV shows, Monty Python. So yeah, I guess there's another cool fact about Python. And another cool yet important fact about Python is that when Guido van Rossum was asked, what was your main goal when creating Python? He said he wanted to create Python to be a programming language that would fix all the major flaws that some big programming languages such as C and ABC had at the time. So he wanted to create Python as a successor to these two programming languages by fixing all their flaws. And one of the biggest flaws that Guido van Rossum wanted to fix with Python was complexity, because in programming languages like C and ABC, they were both really complex, which made them really hard to learn and really hard to code in. The reason they were so complex was just because they had a lot of rules that you had to follow when you were writing your code. And learning all these rules and following all these rules just made the coding process really hard and annoying. And like whenever you wanted to code an app, because of these rules, the development process for coding said app just took a long time because it was just so cumbersome to code in these programming languages. So with that goal, Guido van Rossum created Python to be a programming language that was easier to learn and easy to code in, so it had very little rules that you had to follow, but was still just as capable as C and ABC when it comes to functionality. So that was the inspiration behind Python, and that's why it was created. Now, Python wasn't actually released to the public until 1991 when Python 0.9.0 was released to the public. Now, this version of Python just included core features such as data types, lists, and functions. Now, if you don't know what data types, lists, and functions are, do not worry, we'll be getting into those later on in this course. But 1991 was basically when the first version of Python was released, and it was pretty bare bone. Now, the second version of Python was released in 1994, and this version was titled Python 1.0. Now, this version of Python was quite an improvement from the previous version of Python, since it had some pretty cool features that the first version of Python didn't have. Some of these cool features being functional programming and complex data types. Again, if you don't know what those mean, do not worry. We'll be getting to them later on in this course. But this version of Python had a lot of cool new features that added on to the features that Python 0.9.0 had. 1994 was also an important year for Python because Python was adopted by the National Institute of Standards and Technology to create standards related projects. And this was a big deal because whenever a big organization adopts a new technology, in this case NIST adopting Python for their programming projects, this creates a lot of popularity and buzz around that programming language because a lot of people just, hear about that language and they want to learn that language too because it's getting popular in like a certain industry. So as this big institution adopted Python, Python gathered a lot of popularity. Now, just around 1994 to 1995, Python was presented with another opportunity to expand its wings, I guess, to grow its user base. And this opportunity came in the form of the Corporation for National Research Initiatives, or CNRI. So CNRI basically looked at the programming language that Guido van Rossum has created, and they thought it was worth investing in this programming language because they thought that this programming language had huge potential. So they offered Guido van Rossum with the opportunity to further develop Python by creating a team of developers that would help Guido van Rossum build Python, add new features to Python, and release new versions of Python. Now, as they say, teamwork makes the dream work, and this was true in this situation, as these team of developers added a lot of new, cool, and vital features to Python, which further increased its popularity. And now the next big release of Python would come in the 2000s, or in 2000 to be specific, when Python 2.0 was released. Now, Python 2.0 was one of the most popular versions of Python, with it still being used to this day. And Python 2.0 had a bunch of new features and functionalities, such as Unicode support, a native garbage collector, and etc. And the reason Python 2.0 was so popular was because Python 2.0 was just as simple to learn as any previous version of Python. However, this time, Python 2.0 had a bunch of advanced features that you can use using simple coding techniques. Like, for example, if you wanted to use a garbage collector, you'd have to learn some pretty complex programming languages such as Java or some languages like that, and they had a lot of rules that you had to learn in order to code in them. However, Python, it was still really simple to learn. However, it had these advanced features. So a lot of people started to learn Python because, again, it was easy to learn but powerful at the same time. So due to this reason and many other, Python 2.0, with the release of Python 2.0, Python gained a lot of popularity. And then the next major release of Python would come in 2008 in the form of Python 3.0. Now, Python 3.0 was ultimately a success, but the switch between Python 2.0 and Python 3.0 was rough, as many people really didn't want to switch between the two languages because they just thought Python 2.0 was too good and they just didn't want to switch over to Python 3.0. It was kind of like a if it ain't broke, why fix it situation. And another reason was Python 2.0 had a lot of extensions, so they had like a lot of extensions or a lot of libraries, and we'll be getting into what libraries mean in a second, but they had a lot of extensions and libraries that you just couldn't use with Python 3.0. So if you made an app in Python 2.0 that had like a bunch of extensions that you used to make that app, if you wanted to switch over to Python 3.0, you'd have to rewrite the code for the app you made in Python 2.0 because many of the extensions that you used weren't supported in Python 3.0. So like it was just like a minor inconvenience and people didn't want to move over to Python 3.0 because Python 2.0 was working pretty well and they just wanted to stick with it. However, as time went on and as Python 3.0 got more and more cool features, people started to make the jump and Python 3.0 ultimately ended up being a success. And in fact, that's the Python version we use to this day. Now, the final or the latest biggest update that came to Python was in 2022 when Python 3.11 was released. Now, Python 3.11 had many improvements, but one of the biggest improvements that Python 3.11 had was speed, as Python 3.11 is 80% faster than previous Python versions. And this is really important because one of the biggest flaws with Python, I guess you could say, was the fact that it was slow. Python is a slow programming language compared to other programming languages. So this increase in speed really makes Python, it helps Python not be as slow. So yeah, Python 3.11 was a really major update in Python, and I believe that's the latest version of Python as whenever this video is released. So yeah, that's a brief history of Python. So I hope this helps us understand why Python was created and how it kind of developed over the years. So now that we've taken a look at the brief history of Python, let's take a look at the technical definition of Python, as in what makes Python unique when it comes to it being a programming language. So this is going to be a technical definition of Python and what Python is, but don't worry, we're going to be breaking down that definition in this video. So yeah, we're just going to start off with the technical definition of Python. So get ready. So Python is a high-level, loosely typed, multi-paradigm, portable scripting language with a large user base. Okay, that was a lot. And honestly, I understand if you guys don't quite understand what this definition means because it is quite technical. So why don't we dissect this definition and kind of analyze each part of the definition so we get a better understanding of what this definition is trying to convey. So you'll see here that I have highlighted some terms that I think are really important that we understand what they mean before we can learn what the definition as a whole means for Python. So let's start off with high level. What is a high level programming language? Well, a high level programming language is a programming language that makes it easier to give computers instructions by taking care of more complicated tasks in programming. So what does this mean? Well, in programming languages, there are kind of three tiers of programming languages. First, you have low-level programming languages, or binary, so that's just going to be zeros and ones, or that's going to be like the native language of your computer. That's the only language your computer can understand, binary. So low-level languages are zeros and ones, and obviously, excuse me, obviously, computers can understand zeros and ones great because that's their native language. However, us humans, we can't understand zeros and ones that well because they're just really hard to read and write code in. Like, trust me, I've tried. They're just really hard because you'd have to write a lot of lines of code to do something that you can do in Python with just 3 lines of code because that's just how, I guess, inefficient you can say binary is. It just takes a lot of code to do something simple in binary. So that's low-level programming languages, or zeros and ones. That's what computers understand, but humans don't understand that well. Now, then you have assembly languages, or like a middle tier of programming languages that have like half binary and half English. So these programming languages are a bit easier to understand and write, but they're still really complicated because you're going to have to do like a bunch of complicated stuff related to hardware management. So in high-level languages, you don't have to worry about the hardware, but in middle level or assembly and low-level programming languages, you're going to have to actually worry about the hardware. So you're going to actually have to tell the computer where you want to store your memory, and you're going to have to worry about like hardware parameters, like is my disk full? Is this part of my computer not working? You're going to have to worry about all of those in low-level and middle-level programming languages. Now, high-level programming languages are like are like really abstract. So they're really close to English, and they're really the main goal of a high level programming language is to be as close as to natural language as possible. So yeah, although computers might not understand high level languages because they're not in zeros and ones, humans understand high level programming languages really well, and therefore we code in high level programming languages. Because number one, they're really easy to understand, they're really easy to read and write code in, and number two, they take care of the low level stuff for us. Like, let's say you wanted to store some data in a high level programming language. You're just gonna tell your computer, hey, I want to store this data. Now, if you wanted to store data in a low level programming language, you'd have to do things like you'd have to tell the computer where in your memory exactly you want to store data and all those stuff. So high-level programming languages take care of all the complicated stuff for us, and all we have to do is tell the computer what it needs to do. So write the algorithms. And you might be wondering, you might be wondering when I say, well, computers can't understand high level programming languages. So you might be wondering, well, I thought computers understood programming languages. If they can't understand high level programming languages, then why are we writing our code in high level programming languages? Well, here's the thing, every high level programming language has a translator that translates your code, which you've written in like mostly English, to zeros and ones. Now, we'll talk about these translators a little later on in this video, but that's what a high level programming language is. Uh, Again, the definition on the screen is a great way to describe it, but a simpler explanation would just be high level programming languages try to imitate natural language as much as possible. Now, the next thing we're going to take a look at is loosely typed. So, a loosely typed programming language is a programming language that has very few syntax rules and a language that is just easy to understand and is intuitive. So, before we take a look at what loosely typed is, let's take a look at what syntax rules mean. So, what is syntax? Well, syntax rules are just a set of rules that you must follow when writing your code so that the computer can understand what you're trying to say. Or, in other words, there's just a bunch of rules in programming languages that you're gonna have to follow so your computer, whenever you translate the code from high level to low level, you're not gonna face any problems. This is just to make sure that all the code that you write is really clear and there's no misunderstanding. So that's what syntax rules are. And syntax is, in a way, really close to grammar, as it helps us kind of format our language in a clear and concise manner. So syntax is basically like grammar, but for programming languages. Now, different programming languages have different amounts of syntax rules. A loosely typed programming language has very little syntax rules, and Python is a loosely typed programming language. So it has a very little amount of syntax rules, which is why many programmers tend to choose Python as their first language because it's easy to learn and it is really powerful. So that's what loosely typed is. Now, the next thing we're going to take a look at is multi-paradigm. Now, here's the thing. I don't want to go into detail of multi-paradigm just right now because that's just going to make it really confusing for us. So I'm just going to read out the definition for multi-paradigm right now, and we're going to get into more detail about multi-paradigm later on towards like the end of this week. So I'm just going to ask you guys to like note this definition down or just read this definition and just remember it, but don't worry about it too much at this point. So yeah, a multi-paradigm programming language is a programming language that lets you use multiple different types of coding formats. Again, I don't want you to worry about this. I just put this up here because it's kind of a good term to understand. But we're gonna look at this term from a different perspective later on in one of our future videos, so you get a better understanding. So yeah, for now, don't worry about this term. All right. So yeah. Now, the next thing we're going to take a look at is portable. So what's a portable programming language? Well, you see, some programming languages, they're like created in a way that if you write your code, if you write your code on like a Windows system, you can only run that code on another Windows system. So for example, C, let's say I wrote my C code on a Windows computer. I can only run my C code on another Windows computer. I can't run my C code on a Mac computer. Unless I've written my C code on a Mac OS computer, which in that case, if I wrote my C code on a Mac OS computer, I can only run that code on Mac OS. So you can kind of see how that's really inefficient, because if I was making an app in C, I'd have to write my code for all the different operating systems there are so my code can work on all of them. And again, this is really inefficient. So what portable programming languages do is, a portable programming language, they allow you to write code that can be executed on any operating system regardless of the operating system they are written on. So Python is a portable programming language, right? So you can write your Python code on any computer and you can run it on any computer. It doesn't matter. So I can write my Python code on an Apple Mac OS computer and run it on a Windows computer. So yeah, you just have to write your code once and you can use it as many times on as many different devices as you want, which is the cool thing about portable programming languages. So yeah, that's what a portable programming language is. And finally, what's a scripting language? Well, Remember the translators that I talked about who translate high level programming languages to low level programming languages? Well, we're going to get into a little more detail here. So, a scripting language, there are types of programming languages that use interpreters to convert high level code to binary. So, again, let's go back to the translators I was talking about. So, every programming language has translators that translate your high level code that's written in English to zeros and ones or binaries. Now, there are different types of translators that different programming languages use to do the same thing, which is convert high level code to low level code. And the two major types of translators that are used in computer science are interpreters and compilers. Now, there are a lot of differences and similarities to interpreters and compilers, and I'll list an article for those in our Google Classroom assignment, so check that out if you're interested. But a simple reason that interpreters are like one advantage of interpreters over compilers is that interpreters are much faster than compilers, so they can convert your code from high level to low level much faster, which makes development much faster and much easier because like you don't have to wait a long time for your code to run. So yeah, a scripting language is basically a programming language that uses interpreters to convert your code from high level or English to binary or zeros and ones. So that's what a scripting language is. And Python uses an interpreter, so that's good because our Python code is gonna it's our program is going to get running in no time, and compared to C, which takes a long time to actually convert your code from high level to binary and run it. So that's what a scripting language is. And finally, a user base. What's a user base? Well, a user base is a term used to refer to all the people that use and code in a certain language. So a user base basically refers to all the programmers that use Python as their programming language and that code in Python. So I just want to talk about the user base a little bit more because a lot of people neglect the importance of having a big user base for a programming language. So here's why having a big user base for a programming language is important. So two main reasons that a big user base is important for any programming language is one, because you're going to have more libraries. So what is a library? Well, a library is basically like a file containing Python code that other people have written that do a certain task. So let's say you're making a video game, right? And your video game needs a physics simulation. And a physics simulation is just like a fancy computer science program that does a bunch of mathematical calculations to let you know how physics would be in your imaginary video game. So if I were to throw a ball in my video game, that ball is going to take a certain path, right? It's going to go this fast, it's going to go this high, and etc. To know how high and how fast your ball is going to go, you're going to run it through a physics engine. Now, physics engines are really hard to make because you have to look through a bunch of fancy math and you're going to have to write all the code to convert that fancy math to like a programming language, or to write those fancy math equations in Python or any programming language you choose. So it's going to take quite a long time to create a physics engine. And if you have to do this for every game you create from scratch, that's just going to be really annoying, and you're going to have to do that every time you make a game. So what libraries do is they allow programmers to collaborate. So let's say somebody else, like a university professor who really knows about physics and stuff, let's say he already coded a physics engine that can be used for my video game, or that can just be used for video games in general. Now, what this professor can do is they can take all the code that they've written and they can put it in a library so other people can use his code in their program to make whatever app they're making. So this is the beauty of programming, or any science for that matter of fact, because people collaborate and they build upon each other's work to make new and cool things. And another cool thing about these libraries are that most libraries are free to use. And like for some libraries, you're gonna have to cite like where you use them from. So you're just gonna have to mention that, hey, I use this library. But most of them are free to use, and you can use them wherever you want in your code, however you want to. Now, the most popular places to find libraries for Python are probably GitHub and pypy.org. Again, we'll be taking a look at these later on in our video. But yeah, one big advantage of having a huge user base is more libraries. Another advantage is having more resources. Because let's say you're writing your Python code and you run into an error and you don't know how to fix that error. Now, there are millions of people that write code in Python. So there's a high chance that somebody else had the same error that you're facing right now. And there's a high chance that somebody else already solved that error. And there's an even higher chance that they posted how to solve that error to the internet. So since Python has such a huge user base, what you can do is you can just copy the error message that you're getting and you can paste that error message on the internet or on reputable resources such as Stack Overflow and Geeks for Geeks, and you can probably find somebody that has documented how they solved said error that you're facing on the internet. And you can just simply follow their steps to clear your error. Again, this is another form of collaboration, and it's only possible when your programming language has a large user base, because the more people that are coding in a certain language, the higher chance that they have faced the problem you're currently facing. So, since Python has a huge user base, you're going to find a lot of libraries and you're going to find a lot of resources, which is great. So, that's basically the advantages of Python, and those are the key features of Python. So now let's take a look at what Python is used to make in the real world. So what are the applications of Python? Well, again, as I said, Python has a lot of libraries, and this makes Python really popular because you can almost make any type of application you want with Python. And I mean like any type. Like Python can be used to make web apps using things like Flask, and Flask is a library that you can use. Python can be used to make AI using libraries such as TensorFlow. You can make database management, and you can make the backend to your like mobile app using Python. So you can create databases using Python, and you can manage those databases using Python. You can also create computer vision projects with Python. Now, computer vision is like a type of AI. It's like face recognition and all of that stuff. Python is also used for robotics, so you can make a bunch of cool robotics processes for Python. Python is also used for data analysis. So let's say you have like a big set of data. You can analyze that data and you can try to find patterns in that data. And this comes under machine learning, and Python is really popular when it comes to machine learning. Python can also be used to make virtual assistants. So you can make like your own version of Google or Alexa or Siri. I think my Alexa got ringed off because of that. But yeah, you can make your own virtual assistants using Python. I've actually made one and it's really fun. You can also automate tasks using Python. So let's say you have to organize your desktop because it's really messy. You can make a Python program to organize your files for you. And my personal favorite, you can make video games with Python. This one's really fun because you can show off to your friends the cool video games you've made. And yeah, you can make a bunch of video games using Python. There's a lot of libraries that you can use, and there's a lot of resources you can use. Now, these are just a few examples of many things you can do with Python, and that's the beauty of Python. You can almost create anything you want using Python. So I hope you guys got a brief understanding of the possibilities that Python opens up after you've mastered it. And that's what I'm going to try to do over the next 3 weeks. I'm going to try to give you guys all the skills necessary to make a bunch of cool applications using Python, and we're also going to make some cool projects using Python so you guys get a hang of how it feels like to make apps using Python. So yeah, that's all for today's lecture. Now, before we leave, I'm going to give you guys a really short assignment for today, because obviously every day after every lecture, you're going to have a short assignment that you need to turn in before the next lecture comes out. And this is just to, keep our minds busy and help us think about what we've talked about in the lecture. So today's assignment is going to be pretty simple. All I'm going to ask you guys to do is write a paragraph, so about 2 to 3 sentences, about a cool project that you want to make using Python. Now, this doesn't have to be exactly a paragraph long, and you can go into as much detail as you want, or you can be as vague as you want. But I just want to know, what cool project do you want to build after you're done learning Python? So yeah, type this out and attach it to the Google Classroom assignment. I'll be going through all of them, and I'll be making recommendations on how you could possibly make that project and giving you some resources to read about, something related to that project. And I'll also be posting my favorite project that I read from the description on the Google Classroom stream. So make sure you get that assignment done. And yeah, I hope you guys learned something new today. Uh, and I hope you guys have a great day. I'll see you guys tomorrow on lecture 2. And yeah, that's all for today. See you guys in the next one.